Hey everybody, my name is Lester Martin. Let me get my screen share going here. All right. And I'm here from Starburst, as it says on screen. I'm a developer advocate here. Today we have a webinar. Affectionately have been calling it Starburst 101. You know, hopefully it sounds like it tell you a little bit about everything, a little bit about anything and everything Starburst. And what we'll do today is not only make it a presentation. I got some slides, of course, but we have a workshop, and I'll show you that in just a minute here. That would allow you to do some hands-on activities that I'm going to do as well. A little bit more about me. Heck of a nice guy. Been around a little while. I guess that's good enough. Things to call out on this page are probably that email address you see at the bottom, devrel at starburst.io. That'll find myself and a few others. If you want to contact me just straight directly, you'll probably see it in emails, but it's just lester.martin@starburstdata.com. Linktree, QR code to get you to my LinkedIn profile, that kind of stuff. You should be able to find me. There's only a handful of Lester Martins on LinkedIn. In fact, most of us seem to know each other since we always get each other's emails, messages. If we break it apart today, as I promised, got a little bit of a presentation first. And while I might show a few things along the way just to kind of spice it up a little bit, for the most part, I'll hold off to the second half. So we got about 90 minutes, so probably about 35, 45 minutes for the first part, and then similarly another 35, 45 minutes for the workshop. But that workshop, if you're looking for it, if you can find where the chat is in the interface today, you should be able to also find one that says Docs. And I'm looking up here where I see it, Docs, and it should say Lab Instructions, click to open, something like that. And then the one called Lab SQL, click to open. The hands-on notebook is actually for something else, another course we're doing, so you feel free to click on that as well. That's actually for a webinar we're doing tomorrow. So if you look at that and it looks interesting, we're doing a webinar tomorrow about using Python with Trino and Starburst. What are some of the options and tools and technologies? So that hands-on notebook is something else for that. If you do open them up, you will see something like this, the PDF, just to say it while we're talking about it. I think I need to pop out a full screen so I can see it. Here we go. The PDF should look like, well, let's try it again. For some reason, I'm having trouble moving it to this window. Let's try it the 10th time. Oh, I know why. I'm in this Macintosh full screen here. Let's see if we can get out of that. Yeah, I think when we're in super full screen, we can only see that one. Yeah, there it is. So there's a PDF. It just says Starburst 101 Hands-On Lab. And when we get to that part of the exercise, I'll bring it up again and talk about it. But for the most part, everything in here is going to be some self-contained instructions, top to bottom. There is a second file, mainly because I'm just getting some housekeeping, because there are times when we need to copy and paste something, usually SQL and stuff. And I went ahead and put all of that in this file right here. It's just called SQL. So later, if you decide, or during my conversation, if you want to do the labs with me, I'm kind of telling you about it now, so you can go for it and have fun while I'm kind of setting up. You're more than welcome to do these post-event as well when you're watching this later, whatever makes the most sense, or even hang up on me and do it now and come back at the very end, whatever's appropriate for you. But all the SQL will be in here, so you can just copy all this and paste it into one SQL editor, as you'll see over there when you get to the when you log into Starburst. All right, so housekeeping stuff aside, let's jump on into it. I believe last thing, I guess, one more housekeeping thing. Don't hesitate to add a comment or a question out there in the chat. Even now, you can say, "Hey, hi, this is Lester from Atlanta, Georgia." That's where I'm. Oops. Did it post it? Well, I'm having all kinds of stuff. Lester from Atlanta, Georgia. There we go. If you want to make a shout out, that's great. Let us know you can hear us, see the screen, those kinds of things. And I will be eyeballing, out of the corner of my eye, occasionally that chat window, but I probably won't be staring at it, especially when I get rolling here in a moment. So don't hesitate to put stuff in there we'll be watching for it. Unfortunately, today it doesn't. We don't have it set up where you could actually come on camera or come on voice, but you could absolutely raise your questions or comments in the chat window. All right, let's jump on into the presentation side of that. Hopefully everyone can hear me. Didn't get an affirmation, but I think everything's turned on, so roll on. All right, so like I said, get to know Trino, get to know Starburst, talk about the query engine itself, how it kind of functions at a high level, and then talk about some of the more interesting things that make Trino and Starburst special, which is the fact that we can talk to and connect to a variety of data sources. You're going to find out, as I'll say it many times, really ideally aligned well, and especially well with something like a data lake, object storage, HDFS, something like that, where we can be the compute engine, it can be the storage engine, but we can talk to a variety of different data sources and systems, as you'll see shortly. And then we'll finish up the kind of presentation stuff with some interoperability, again, following that optionality concept of the connectors, talk a little bit about data products, and then we will jump straight into the tutorial, the workshop. And my plans at that point, or I will go through those activities. What I won't do is do a dual screen and walk every instruction and do it, some of the stuff I've already done, but I will, for most of the part, for those things or setup things, I will take a few minutes and look at that PDF and just make sure, you have some points of reference. And all this is being recorded, so you can go back and listen to it later. All right, jumping on in. Getting to know us, Trino and Starburst. Well, you probably can't talk about data analytics as a whole, not just Trino, without thinking the old history lesson. I promise to keep it short and brief. And the history lesson, fortunately for some of us, we got to be around during all of it. It was really fun and interesting. It came down to the fact that, especially with the internet, the amounts of things being published, amounts of tracking of things, and the desire to start actually not getting past human tracking to even like systems tracking or sensors, those kinds of things. We found ourselves in a situation where the data size from the footprint, the data size from the querying and stuff really was stressing the value and actually the scalability of current data solutions at that time. Meaning, hey, I have queries and questions and comments, maybe even just data that doesn't work or fit in my system today. Or if it did fit, maybe you just simply couldn't afford it. That's also another truth as there. So a lot of open source big data solutions came out. In fact, the kind of grandpa of them all, Hadoop, came out. We don't have to run through all that Hadoop stuff, but I will say that Hadoop, pretty early, the folks at Facebook kind of chimed in and said, look, we don't know this weird Java MapReduce API thing, but we know SQL. So they wrote a wrapper on top of Hadoop that said, hey, I can create and define tables, run queries, and then let that be torn down and run this size and scale solution. So Hadoop wasn't trying to be faster than anything else. When it launched, it was really trying to solve questions that just weren't solvable up to that point. It couldn't run, if that's fair. And then, as it said at the bottom, in the earliest of days, that actually meant things went kind of slow. And when you go from no to slow is a win. But we all know that slow isn't where we want to be, and we constantly look and strive for things. And in fact, Apache Hadoop itself has, constantly tried to go faster and those kinds of things. But at that same time, the good folks, another team, the good folks at, what we think of Meta today, but back at Facebook in the day, were kind of tasked with, that's cool. I'm glad we got those questions. How does it go faster? And they took an approach that said, hey, there's a lot of things that Hadoop is doing based on the fact that these things that I'm asking should take a long time. So there's a lot of resiliency and auto restarting all over the place that forces Hive and arguably some of the other distributed frameworks to take a little longer to do things because they're built for, nuclear bomb proof. We're waiting for something bad to happen. Okay, I can fix that. But the reality is there are definitely sometimes some things that we can actually get a query, that should be able to come back pretty darn fast. And at least I'm going to use the old phrase, interactive querying kind of window. So a human or a process is pushing the button and is waiting for an answer to make another decision and likely ask yet another question. So we're looking for something that can, be human friendly and that kind of stuff. Is that sub-second? Is that multi-second, single second? It all depends on a lot of, it depends, but definitely Presto, as it was called then, was significantly faster than Hive. And we can go into more details another time and break it all down, but that was very, very important. So there we go. And it actually started even the earlier days of getting back to that separation of storage and compute. So a SQL-based, an engine built with SQL in mind, not a framework that was built for kind of batch analytics that wanted to lay on top of that a SQL approach to itself. And just for fun, because I kind of suggested if you'd read between the lines that, hey, well, then this thing wasn't good for long-running queries or long-running processes. And often what are we talking about there? Sure, sometimes it is just a query. Find this crazy aggregate, over the last 16 years of data. But often we're talking about transformation processing. We're talking about getting data from a source, standardizing, cleaning, enriching, validating, joining, all that kind of good stuff. And we do that all the time. And to be honest, the truth is pretty early, even though Trino, in the earliest of the days, Trino, the open source solution that Starburst is built on, even in the earliest of days, it did have that concept. I said, what if something broke, failed, and you had to start all over again? Even with that, the speeds and the it's not about mean time to failure. It's about how often does it fail. Got to scenarios where many people were using this interactive query engine for their long-running transformational activities as well, despite some of that fault-tolerant issues that were there at the time. I'm not so sure if I have it in my slides, but I'll go ahead and tell you the punches. Good news is later in life, because we always ask for more from everything. Over time, some fault-tolerant execution environment concepts came along on board and actually allowed us to have those failures incorporated and moved on and that kind of good stuff. All right, so ETL processing on Trino, on Starburst, really started happening almost immediately after we started using Trino. And Trino, to be honest, Trino, and I'm not going to say all of these logos, because when you get into this hyperscaling kind of B2C kind of spaces that we all know and love, often these organizations have very rich, large, sophisticated engineering teams. Amazon's a great example. They make their own computers. They do, they're different often than a large department store who can only spend so much money on things like IT and stuff. So they've been using Trino, pure open source, built all their own infrastructure, groups, teams, everything around that. And while these numbers don't look all that impressive in some ways, easily up in the petabytes, these numbers are pretty old because most of these companies don't like to share too many details to us. We got to glean them at conferences and those kinds of things. But Trino's been out there, and Trino's being used by the big players that we see all over the place. Now, it looks like I got me a good, let me just load it out, a good marketecture slide here, so I'll be easy on this one here. These are just things that people see happening in their environments. So some or more, all of these might make a lot of sense to you on the left here that you are incorporating or understanding or feeling. But then, of course, the flip of that is, okay, the trend's awesome, but what's the pain that I'm feeling with something like that? We'll just look at the very bottom with growing use of open source. Trino is open source. It mentions a thing called Apache Iceberg. That's a table format. More on that as we go along. The pains on that one are kind of what I just said a minute ago. Open source, great. How do you manage open source? And historically, I think people fall in one of two camps. They fall into that self-managed world, or they look for a vendor who either is the heaviest producer of that framework, or maybe a vendor who doesn't really contribute or help write that software, but can give you a really, 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 really good deal. So there's different kinds of vendors out there. It depends who you're looking for. You are always going to get the most knowledge from the vendor who is really the open source backer and supporter. But I'm not going to suggest that that's the only option you ever have. We can talk about Apache Kafka for a minute. and say, do you have to go to Confluent? Can you run it yourself? Sure. Do you need to go to Confluent? The folks that sit around that, we know they are the experts, but there are other people out there as well, Red Panda and other examples like that. And of course, I'm hinting around a number of things like cost, even though I didn't say it. I've been cost of the reason another reason, like I said earlier, even if your solution could scale, sometimes the cost to scale is an issue. So that often, to be honest, almost always is a factor about what we talk about when we have large data sets, large data analytic needs. So what performance, what cost, we're trying to find that kind of mix and match. And I think it's fair to say you do have a number of choices, and not only open source. You have other opportunities, and that's okay with us. It's okay with Starburst, a company that supports this Trino environment with the rest of the community, because we do believe in not just one way of doing things. We believe in this term called optionality, and optionality may mean to some people, flexibility, configurability. Sure, we can deploy anywheres and that kind of stuff. But to be honest, it's more about what we can talk to, connect to, what fits into your organization. And I'll try to talk about that phrase optionality as I go along, because I truly believe we're dare I say it, about 3 decades, really the only company that I've ever really worked for, or a customer of that, whose main mission is not to tell you you've done something wrong and tell you how you ultimately have to do only this to be solutioned the best. We say there's a lot of options. There's a lot of good ideas. And there's a lot of constraints and prior history and legacy and technical debt. And we are definitely a tool that understands that and works well in that not just hybrid, but multi-cloud, multi-data source, multi-schemas, all kinds of good stuff. So we'll see that as we continue to go on. All right, so there we go. A lot more Trino stuff. Yep. Good, important stuff. Good, pretty slide. Very open, vibrant community. Yep. The founders came here, created us. We're still the biggest committer to Trino. And I don't want to say those names per se, because I want you to figure out yourself. But there are other companies that run Trino. We're not the only one. And we believe, we'll talk about some of it today, we're an open source plus model, like pretty much everyone else. So there are going to be some things that we do that are outside of Trino, especially maybe today on our data ingestion space, maybe our AI tooling integration stuff is stuff that's not core data lake analytics engine Trino. It's Starburst proprietary stuff. And maybe this picture can help with what I'm trying to say there. There's this open source engine called Trino, trino.io. You can go check it all out. And what we're trying to do is do what all open source plus kind of vendors do. Hey, bring more things to bear, more support, more tooling, more help to make it a lot easier for folks to roll this thing out and use it in their environment or in their instance of the public cloud, whatever place it's trying to be. Absolutely, open source Trino has a lot. I mean, this part of the slide actually looks a little confusing because it kind of suggests, Trino doesn't have data connectors. It absolutely has a lot of data connectors. We add to some of those. We enhance some of those. Some of them we just say as a company, maybe we don't support because we feel like they're not being all that used, but it's still there. Codes in the engine. And then we really take a lot of pride in bringing additional performance benefits. So we always, like any open source plus company, have to make choices when let's go tackle something. What do? Do we directly put it in the open source environment? Do we put it as a value add? If we put it as value add, is that a forever strategy? All kinds of stuff come to bear. But it is fair to say Trino itself is a little bit faster, and probably more than a little bit. I'll save that for another webinar. Faster than core Trino. And I also think it's fair to say if those ideas fundamentally further advance Trino as a whole, then I would look for much, if most, maybe not every single thing, but many of those features over time to percolate down into the engine if they didn't happen initially as well. The things that are easier to make decisions, of course, on are something totally new. So we have a manage ingestion pipeline framework that works with Kafka and S3, and it builds Iceberg tables and it auto maintains them. Yeah, that's all proprietary stuff for us today. It's not open source, but it would work just fine even if you had that plus something like Trino. And then you can see it across the bottom. I think I have a slide to that effect. We kind of put those and we just look ahead. We'll see it then right there. There's not a slide. That's good. We primarily put those into two product camps, even though arguably you can think of them as the same. Starburst Enterprise down the low left, Starburst Galaxy on the right. Really just meaning enterprise is our classic enterprise software kind of model. Hey, we'll help you. Here's the bits. We'll help you get install it anywhere or wherever you want, anyway, or whatever you want. Kubernetes, bare metal, on-prem, in the cloud, somewhere in between of all that. Awesome. And then Galaxy is our software as a service, all totally hosted model, fastest way to get up and running in Trino. In fact, I will use that in all of the workshop stuff. The workshop could be adapted to something else, even probably open source Trino, but I have everything you need and instructions to make it painless to make it all work with Starburst Galaxy. All right. Yep. We're all over the place as we should. I think it's fair to say, definitely on the far left, we're heavily, the bookends, I guess you would say, we're really entrenched, like a lot of vendors often do, because it takes a long time and effort to get into the finance world and the telecom world. So, long involvement channels to get engaged in there, and then those really help drive further adoption to a lot of other folks. So those are some of the biggest customers of ours. All right, that's a lot of what does it do at a high level. I don't think it was that. It was what's benefits you get, all that kind of good stuff. Why don't we take a quick minute and do a little something different, do a deep dive. Now, I'm going to say, see, there's a picture and there's a picture, right? Oh, that's a lot. I'm going to say, let's take a moment and say, okay, if what I want to tell you about is, oops, if I can get, here it comes. There we go. I want to say that this is Starburst, but in all fairness, this is a user interface to stuff. And this stuff, we will see this. I'm clicking around here. We're going to see this stuff in the workshop very directly and that kind of good stuff. But this stuff, isn't the core. What's really happening, this is usually configuration or interfaces, submit things at the lowest level. What Starburst really is, it's Trino. It's the open source engine. Let's get back into this thing here. And that runs, arguably, SQL. As I mentioned, tomorrow I have a webinar with Python. What are some of the Python options? Absolutely. I hope you come to that, or at least ping me if you don't, or register. Go to our events page, resources events off starburst.io, because at least then we'll send you a link with the recording. If there's some interest in that, you can kind of click through it a little faster if you don't want to listen to my full spiel. I have another colleague with me. But at heart, this engine is what? It's an open source data analytics, open source processing engine, whatever term you want to call it. And for those to work at size and scale, they have to run on many, many machines. We call those machines working together a cluster. And then there's almost always kind of some server types or node types in there. And the primary stereotypes we have for the brain, we take that brain worker kind of model instead of the peer model. We say, hey, we have a thing called a coordinator, and that coordinator is the one that does all the hard. That's a tough way to see it. All the intellectual work of figuring out what you want to get, and then what possibilities are available in size and scale and schedule, and then fire off into our worker family, the scalable worker family, to say, get that thing done, run it to ground. And if you had to draw a picture, a little more details, it would look a little bit more like this. And if you bear with me, I will just take about 3 more minutes and click this and try to make all those arrows not just hit you all at once. Basically, what we're really saying is people or processes or AI agents or humans or whatever, MCP servers, whatever, are making questions to our coordinator. And we'll keep it simple. It's Freddy. Freddy's typing, select this column, that column from this table, join with that table, whatever. So they're running some SQL statements. That coordinator, of course, is going to do authentication, authorization, check all that stuff that it should. All looks good. And then it's really going to say, I need some metadata about those structures that you're asking for. And metadata is really kind of two camps. And this is universal, right? It's metadata that says structure, and then it's metadata that says usage of said structure. How many rows, how many records, how many distinct values, or ranges, all that kind of good stuff. So with that structure and that usage set of metadata from anywhere, so it depends where we're getting it from. An open source file format like Parquet sitting on in an AWS S3 bucket has different things than an Oracle system would have, and so on and so forth. So we're going to figure all that out. So this is generically going to get that metadata and then say, I know what we need to do, and I know how wide we need to run it and all that stuff. And then it's going to signal work into our workers and say, do that work right now. And that work, while the arrows suggest data only comes in, these are read and write operations we can do, but just kind of suggesting data flow. So bringing that data from wherever, and this is the stuff we're going to talk about in a minute, the connectors, the catalogs, that kind of stuff. How do we do this generically? And then once we figure all that out, we're just going to pipe that info back to the customer. So the customer is unaware of what's happening here. The customer thinks this is, I don't know, a database, I guess you could say. Hey, Starburst, the database, Starburst, whatever. And we're not really a database. We're a SQL query engine. What's the real difference? It's this on the left. Databases have highly preferred ways to store their data for themselves. And databases have a query engine, cost-based optimizer, all that kind of normal stuff that database kernels have. So think of Trino and Starburst as, yep, it's that cost-based optimizer logic and thinking of how a database works, but having lots of extensibility about where the data is getting persisted and retrieved from. Okay, big picture. Hopefully not too overwhelming. Don't see any questions. I'll keep on and moving. All right, connectors, catalogs. What are we trying to get here? Well, the terms I want you to hear are single point of access, and then the benefits of a single point of access. Old school might have called it data virtualization. I'm hesitant to use that phrase, even though technically you'd argue that we are. One of the ways to describe us would be that. But it really is about what it sounds like. We need to be able to connect to and talk to a lot of different systems out there. And systems can be systems, talk to Teradata. Systems or data sources could be concepts like, an Apache org file sitting in ADSL, Azure Data Lake, ADLS. Yeah, get these words mixed up in my head sometimes. It could be files sitting on some file system. It could be an index in an Elasticsearch environment. It could be a lot of different things. We talk about that. And in fact, we don't necessarily have a rigorous, a connector has to fit into a type of connector. So we see these kind of types, data lakes, relational systems, NoSQL, so on. Those aren't a rigorous thing. Those are just a logical way for us to clump those. But what it really means is we have an open source model, what they call an SPI, Service Programmer Service Platform Interface, SPI. And we say, hey, here's what it would take to be a connector in our world. And it means things like how, if asked by this core engine about, show me what data types you have, show me what tables, schemas, all that good stuff, and that further metadata. So those questions that the coordinator needs to ask to make decisions about how to most appropriately do work, those connectors need to be implemented by someone to satisfy that. And then they're also going to do not just metadata. They're going to be asked to do things. Go get this information, get that information, so on and so forth. And the vast majority of these, I think it's fair to say, are written and implemented and deployed with the open source Trino project itself. Often go look at the list side by side on the screen, but I'll just say, let's not do that right now. And then you'll see that we, like I said earlier, we'll support the vast majority of those. Some we might say, so old, no one touches that anymore. Let's just not, agree to that unless we have a customer that wants that. Some we do net new. Maybe we have a really good relationship with this other vendor, and we want to make sure that we have a dedicated solution for them, or maybe enhanced one of the open source ones. And then sometimes, usually around the application space themselves, we might just go do something in a partnership with someone else. You see things like Splunk and even Salesforce is probably a better example of something like that. It's an application, yet ultimately to us, we can make it look like a set of schemas, a set of tables, so on, so on, and so forth. And those are software, these connectors. But when we configure one of those, we have what we have been and still call a catalog. I'm hesitant to use that word nowadays because catalogs in the open source modern data lake, this version of the modern data lake, I guess, could be replaced with, or is replacing what a lot of people have referred to historically as like a meta store or a meta data catalog of some sorts. So a catalog in our terminology here is a couple things, but the primary thing it is an instance of, a configurable instance of one of these connectors. And I will show you what I mean by that. Over here in Galaxy, I have a bunch of catalogs. These are ones I've already set up. And if I want a new one, now Galaxy is going to make it easy. They're going to do it from a wizard. If you're in our enterprise environment, it depends how you deploy it, but ultimately it's going to be driven out of a properties file. So you want to connect to, I was looking for Mongo. There we go, Mongo. I want to make a catalog that connects to Mongo. Again, we're going to use a guided wizard, which has sometimes slightly less flexibility than enterprise does. But for the most part, so us looks like we can run, connect to Mongo in Galaxy if it's in the public clouds. If you're running it locally, you might have to do something a little different. But, all we're going to ask for, where is it? What is it? Those kinds of activities, test connection. And then it's going to show up in our list of catalogs. And then those catalogs are going to get deployed, guess where? To a list of, to a server or servers. So Galaxy shows 3 servers here, 3 clusters, I apologize. And then for each cluster, what is configured? So I got about 15 different catalogs set up here. The gotcha though, and you're going to see it if you look really close, things like this select from as like this 3-part naming convention. The gotcha is that. And it's not a gotcha, it's just a call out. Most of the time when you connect to a classical database, per se, MySQL or MySQL or SQL Server, Oracle or something, you probably have something like schema.table or even database.table, whatever they like to call that unit of clumping. Ours, we're going to need 3 parts, catalog.schema.table. So if you're going to fully qualify names, you do that. You can absolutely do all the, use commands to narrow it down. In fact, you'll see the labs that do that where you don't have to, you always see the 3 parts. But for things that run, behind the scenes, all headless things, of course, let's fully qualify them, drive that via properties and all that. It won't be a big deal. But our engine has to, one way or the other, know those full 3 parts. Otherwise, it'll go, what are you talking about? Where do you have a schema called instructor, but which one of those catalogs are we talking about? So what's the benefit of having all those catalogs in one place? A single point of access. What's that benefit? Well, that is benefit number 1. As you probably just saw, I can come to that environment and log in as a human or a process, and see a bunch of things with one connection. I have a lot of different data sets that are available to me. Now, single point of access, one could argue, is that all that valuable? Aren't you still configuring it? Yeah, but if you had 1,600 clients to install to keep active, and everyone needs to see 10 different data sources, then we have 1,600 clients times 10, 16,000. You have a lot of connections to keep track of. Maybe single point of access is going to provide you some administrative relief. It's absolutely going to provide frustration relief from individuals, if that's the case, that have to connect to a lot of these things. And we're going to use security, of course. So single point of access means single point of governance security, lineage, those kinds of things. So we don't have to let, just because we see 100 things doesn't mean that every person or every process needs to see 100 things. It just means those are the possible lists. And a really cool feature of this, and you have to decide where it's most useful or not, and really cool feature is a concept called federation. And federation to me is just a big fancy word for, hey, I can write a query that can join data sets from different data sources. So, for example, I could write a query that says, hey, I want to come to Starburst. I'm writing a query that's joining my data warehouse, my data mart, my data lake. And assume those are three completely different technologies. What did you do in the good old days before this? Especially if you're being an interactive developer trying to figure things out, you are probably making three different requests of those different data sources, bringing them to yourself, and then trying to decide what to do. Or conversely, behind the scenes, you've been constantly doing a lot of ETL movement to make sure there really is only one place that everything is there. So all those options are still valid. They're all still good. There's reasons to do every one of those options. But the federation element itself, what we're really just trying to say is we're letting you use standard ANSI SQL to say, join me data sets all over the place. And we're expecting that engine, that Trino engine, that Starburst engine, to be as intelligent as possible. Use all that metadata we talked about, use the query being asked, and make some strong decisions that limit what you have to go get, limit the work, or sometimes push down some of the work. There's lots of things that we can do instead of just simply go drain a warehouse, drain the mart, drain the data lake, and then crunch it together. We're going to let Starburst be a query engine, like a database, be smart and intelligent, and let us as humans, or even processes that we helped point in the right direction, run queries across data sets all over the place and get a real answer. All right. Cool, powerful stuff. Always love questions about federation, like, would I want to do it this way or that way? But it does, main thing I want to say is it allows you a lot of opportunities, especially when data sets are split among a lot of those spaces. Do you always need to push them into one or push them in from 20 to 10? Yes or no? Those are decisions you get to make, but we're giving you options to say, hey, if you don't need to or not ready to, or maybe the scenario you're using runs every 20 minutes and this federation is beautiful, works, it's better than building a whole infrastructure to put it in one place, things like that. All right, I'm inventing questions from you guys, so I'll keep marching forward. All right, open data Lakehouse. This is a conversation quickly about, in all fairness, I'm going to introduce Apache Iceberg in this conversation here. And really just going to give, I'm not going to read all this at this point. The data lake, we're kind of suggesting the earliest days, the Hadoop days. In fact, Hadoop, for really good reasons, advocated a solution that was bring storage and compute together, put them all on the same cluster and everything. And the main reason was because to do work in a very wide set of data that we have to, use a lot of machines and that kind of stuff. And the big win that Hadoop did was it pushed the processing to the machines where the data was. They called that phrase data locality. And it really made a big difference, especially when network speeds, even in a data center or even within a rack and that kind of stuff, aren't as good as they are today. And in fairness, that data locality is still a very sacred belief. It makes a lot of sense, but the reality is we needed to kind of go back and split apart storage and compute, mainly from the economies of scale that we've got since then. Obviously, the internet, the network speeds had to speed up and that kind of stuff, and allow us scaling storage and compute different from each other. It wasn't unheard of if you had a ton of data, but hadn't figured out what you're doing with that data yet to have a gigantic cluster, because it took that cluster to be stood up to store the data. And it also, so that was bad because it cost a lot of money and it was sitting idle. And it was also bad when we had a decent amount of data, but a gazillion questions. And now we're the other way around. We sized the cluster for the data, and then the compute was being starved out with busy neighbors, noisy neighbors, and that kind of good stuff. So data lake got us pretty far. And then nowadays you hear this term Lakehouse. And I would just say Lakehouse, think of the data lake benefits, a lot of flexibility, cost, that kind of good stuff. But add those things you've been thinking about and been using and used to from your data warehouse over the years, things that really made it feel more like a true engine of the cars. It did more than just select. The data could morph and change. I still say these are analytical frameworks and analytical engines. Personally, I still believe they're rarely the source. They're usually the target that we move from an operational system into this giant environment. But we do allow things that maybe weren't there originally, which is immutability. Originally, we said, hey, nothing ever changes. And there's lots of good reasons that still makes a lot of sense. If we're reporting on something that we didn't invent, do we want to change data? Well, we all realize over time that, well, not everything is time series immutable data sets. Not everything is simply the transactions on my checking account or simply the sensor reads off my car's various components. There are times that we just want to have an understanding, we want to do analytics on a customer. Data about customers change all the time. We need to deal with that kind of stuff. Our catalogs, our inventories, all that kind of good stuff. So what do we use so synonymous to us here at Starburst? We would probably try to not say Apache Iceberg is the only way to do a data lakehouse. There are a few of these, what they call table formats out there. Iceberg and Delta Lake being this very late 2025 are the two predominant ones. There's another big one out there called Hootie that has a pretty strong user base and following, and really good space, really good. They all fit a use case a little bit better here, a little bit better there, but ultimately the Iceberg is the one we feel, and I think industry feels, is the most universally adoptable, acceptable. And again, if you've never heard the word iceberg, go to LinkedIn, type iceberg, and you'll see what I mean. Everyone has an iceberg answer. I've been working on this stuff for 4 years, and that came after about 8-9 years of the precursor to all this, things like Hive and Presto and Trino and stuff. All right, so ultimately, there's a lot of words. I was letting you glance at it. It lets us start to a lot closer treat these data analytical tables as tables that you might see out there. Again, it's not a general purpose replacement for Postgres. It's not a general purpose replacement for any OLTP oriented transactional processing, RDBMS solution. It's not a database. Can you make it work because of its operational statements and stuff? You could, but probably the size and scale of the updates and the churn and the number of concurrency change users, probably not going to be that answer. But the flip of that is, do you have some of that happening, and do you have extremely high concurrency on your reading, your querying, your analytical users? We're still in a great place. In fact, a little bit faster, a little bit better than things like the Apache Hive that we've all been kind of using for many, many years. All right, quick builder slide that says, hey, maybe a different way to look at it, Open Data Lakehouse. It says, hey, separation of storage and compute. So whatever you want to store your data down at the bottom, we'll just look at the middle one, S3 buckets or S3 compatible bucketing concepts. Files, because data lakes or object storage, they really just store, files, and kind of like directories of files, but files. And the file formats, they're CSVs and they're JSONs and all that. But to get the kind of higher order, the higher performance, and all these great features, we probably do need to evolve past our raw data being supported in those formats and then transform them into something that's going to work a lot better, faster in our Lakehouse analytics space. On top of the file formats are this concept called a table format. And I didn't use the term, didn't really define it. A table format simply means the mechanism in which we describe and store the metadata about a table and the reference to where the data lives. Yeah, good stuff. Oops, wrong direction. You need a compute engine or more than one compute engines. There's nothing stopping us. And in fact, that's the benefit of doing all this from the lowest level up, from the generic data lake to the widely accepted file formats to the universally understood table formats. You're doing all that so you can have different engines as needed. Maybe you only need one engine. That's beautiful. We love it to be only Trino, only Starburst. But there may be scenarios where you need other engines. And why would we want to make that data why do we, if we don't have to, we don't want to make two copies of it. So we can have two different engines query it. Let's have one copy of it and let both of those engines query it, update it, whatever's appropriate. And then we like to say, we draw a little line there and kind of suggest this side of that is the lake, the data lake, Lakehouse. But we also get, as I said earlier, about you didn't do anything wrong. We get there's a lot of data in a lot of other places. And why would we want to say we can't do analytics on it until you cross that river or come to the lake and import it and all that good stuff? Of course not. That's not true. You may find reasons and times, some or a lot, that data should or could move forward, sometimes more for performance. But you just have a lot of different data sets and a lot of different data technologies, and we want to make sure that is also included in that fully exhaustive, open data lake out there, not just certain sets of data and certain formats and that kind of good stuff. All right. And yeah, of course, we wrap it with all the enterprise qualities that we all come to expect. All right, open data lakehouse. Now, we are not going to run through that, but if you remember earlier when I had like a 4-stack, these are those 4 stacks you saw earlier, the engine, things like, yeah, that you can read here while I'm kind of wiggling my mouse. And really, I'm really just trying to show you a couple things. Each one of these, can be continually subdivided into what does that mean, what features and stuff. And the last thing I'm going to do is walk through all this with you right now. But you're going to see a number of these things, especially when we get into the workshop. Some I'll call out. Hey, we're doing a data product right now. And many things I'm not going to call out. They're just happening. So I want to kind of give you the belief and the understanding that these are very sophisticated, yet approachable, but sophisticated solution sets that didn't just show up last week. They've been around. Core Trino itself has been well past a decade at this point. And across the bottom is what we saw on the left. Lots of different data sources. Across the right, lots of different people and processes. So each one of those, like I said, we could take a whole office hours and dissect one of those for a while. Some like the cost-based optimizer. I've done like 3-part webinar series full of workshops and stuff that some of them are not 5 minutes. Some are hours, if not days, to really kind of master. Okay. The good news is it is 48. So I'm about where I wanted to be to stop talking. And that's probably a great time because I'm in my last section before we jump into the hands-on. And this is something that we call data products. Probably a term you might have heard about, maybe terms like data mesh you might have heard about. I will talk about and show to us data products. There's the conceptual world of what a data product is, which we can talk a lot about. And then there's what do we, not Trino, but what does Starburst package up as, hey, here's our data product solution. And I think they actually, of course, are aligned very tightly, but sometimes the theory could be all kinds of stuff. And then what do you do that fits into said theory? I would say it's ultimately about this. When a person comes to your single point of access and you say, log in, and then they say, whoa, my goodness, I have all this stuff. What is going on here? I'm just I'm finding stuff all over the place. That may be great. For some users, that's exactly what you want. And there's still universal searches, to kind of start looking for, you got stuff on Pokemon, help me out here, brother. Okay, yeah, you got these different schemas and tables and that kind of stuff. So searching and all that stuff is valuable. But what might be just as valuable under data products is for someone that owns maybe the air and space kind of domain at my enterprise here. Maybe they create one or more data products of which now they're saying, hey, I want to, I've curated a set of data sets for the purpose of, hey, you care about air and space, come here. So I can tell you all about it. I can show you, what these tables are. I can give you hopefully some better descriptions, that kind of stuff. If you want to just go see it or preview it, I can kind of click on those activities. I can go straight and query the data sets, as well as maybe I'll tell you some ways to leverage these data sets. So a data product, fundamentally, you'll see later, is aligned to a schema. And a schema has things like tables and views and materialized views. But what a data product itself is a way to say, hey, in a different user experience, how can I bring these well-curated, well-documented, owned data sets? I'll just call it market them to the masses, and realize that when you really, really, really want to run that data, it really, really is just tables and views and that kind of stuff. And in fact, just to kind of make that point a little bit, possibly a little bit clearer, look at the, where did I bear all this good stuff? There we go. Here's this one called My Cloud. It's an Amazon S3 backed catalog. And what do I have? I have a whole bunch of schemas. These little icons suggest schemas. But then I have this weird other icon that says, what? This is actually, it's still a schema. It's a schema called aviation, but it's being wrapped with a data product. So they're really, end of the day, data products are not fundamentally anything different from runtime, querying, and checking. It's a way to advertise, promote, etc., well-documented, well-curated data sets, including how to find people and stuff. And I'm showing you the Starburst Galaxy view. If we were an enterprise, it actually has a few more features like socialization, rating, has another level of granularity called a domain above this. But arguably, there's a gentleman here that likes to use an analogy of a pharmacy or a drugstore, and I like it a lot. Come into the drugstore, you read the signs on the roof. You got a headache, you go find the aisle, talks about pain relievers. Here we go, headaches. You grab the bottle, you flip it around. You don't really get to take it yet, but you learn a lot about it, and you found it via this popular semantics of a store. You found the labeling. So the data products themselves are pretty much like the box around the bottle of Advil, as well as the whole Walgreens or CVS, if you live in the US of A. Analogies are store names, etc. So I don't know if that helped or not. I'll click to these slides. I will not read them all around these data products and see what it says there. Yep, biggest challenge, how to help people find data sets, help them understand those data sets. And I'll go ahead and tell you one more nice thing. That data product space we offer in the AI environment, other webinars that we talk about here, we're not going to jump on that today. We have a lot of strategies, including, directly, I put them on screen casually so you can see it earlier. I didn't say anything about it. Connect to various models and stuff and expose all that as SQL functions, etc. We have, MCP server included. You can use your own MCP server. But we also have an agent, our first agent today, only one. And our agent today sits on top only on data products. We're going to opening that up to allow it to do other things, but we wanted to do that because it's easier to show with more metadata, more uses examples, more noise and conversations around not something more than just a schema and a table and a column definitions, that those questions that we ask as humans start to be, understood a lot better, especially when there's weird things like columns that have the flubber indicator, which has values FQ and Z and 14. You can document all that stuff, and now your questions start to make more sense and they get validated. All right, so data products produced. Yep. Shows all this kind of information. Yep. One cool thing about these data products, some places, some shops, not against anything like that, have this big exhaustive power move about how best to represent the mesh, the data products, all that stuff. That's all still important, but don't also, at the same time, don't prevent small groups or or opportunities for viral TikTok videos by letting someone produce a data product, letting the enterprise know about it, and then maybe drive some adoption that they weren't planning. All right. Yeah. Discover, create, publish, and manage these highly curated schemas out there. So data producers, data consumers, it's kind of like a marketplace. All right. It's a little bit behind schedule, but we're at the workshop. I hope somebody's did take some time and download that PDF. If you're watching this later from YouTube or one of our video assets or something, and the information is not available in the documentation, down below, and you do want to work this exercise, add a comment there or send an email to devrel@starburst.io or something and say, hey, I'd like to try this workshop myself. So let's make sure we find a way to get you a copy of that or get you signed up for the very next similar webinars. You can get the most current project set. All right, so what are we going to do? We're going to do this. We're going to have a solution that says someone has already preloaded whatever technology, it suggests Flink, but whatever. Someone has loaded some, it's actually New York City taxi ride information. So they've been landing that stuff in an Amazon S3 bucket for us. Nice and neat. They're already helping us. It's already happening. We can go look at that ingestion process another day today. We're going, great, someone did that. I'll take on and run from that. And what do we want to do? We want to put a table or tables around that raw data. We want to build a bronze tier. We're going to build a medallion arc. It doesn't say it here, but we're going to build that medallion architecture. We're going to build a bronze or raw tier that represents the data as received. Then we want to apply a little bit of thoughts. We want to do a little bit of analysis and say, hey, quality, all that good stuff, naming conventions, is that data in good shape? We want to bring it to that silver level, something that is truly reportable, that we agree, yep, that is the facts, and let me stay away from the word facts. Those are the values that make sense and we agree, and feel free to, run up the flag and run reports and all that kind of stuff against this highly structured, high value data. So a silver layer, a structured layer. And then we're going to say the reality is, though, often people can run queries against that, but often either because there's a bunch of different tables, or it may look a little weird or complex, or maybe we need to join with other data sets, we might build a gold layer, a consume layer that's really focused on query-focused data sets, QFDs, I guess you could call them in the old days. And that's what we're going to probably drive our core data products on, or drive our core reporting dashboards and that kind of good stuff. And we're still going to allow the right people that need access to go deeper than just that tier. But for the high repeatable users that we know their use cases, absolutely, we're probably going to build a special data set or data sets for them. So we're going to build all that medallion architecture using Starburst, and that whole lab's going to focus on that. And just for fun, I'll throw another twist in there. We're going to show you that single point of access. We're going to use some Snowflake data that's lookup information. So we're going to focus on New York taxi rides. So we're going to need some boroughs and zones and that kind of stuff information, because our questions that we'll see at the beginning of the lab guide really are like, hey, what kind of weeks, days of week, months of year, and that kind of stuff by the boroughs in New York are taxi riding most popular. So we got a simple set of questions, a simple set of data, because we want to do it all in the next 20, 30 minutes here, 35, 40 at the worst, and see it all. So we're going to build all that right here. It's all documented. If you want to do it after the fact, want to try to do it with me, that's great. We're going to go pretty fast. And then ultimately want to wrap that up in a data product if we have time as well. So let's get on to it. Let's do it. All right. I'm going to do myself a teeny tiny favor. And I'm going to hit the run button because my server shut down. It's a free cluster and it's sitting idle. All right. I need that PDF. So that PDF is coming on screen. And like I said, I'm not going to walk through all these steps, but I will point out a few things at the very beginning. So there's all these connect to this, build the bronze, the silver, the gold, build a data product kind of layout that we're imagining. Well, we'll also say that this thing is big on not big on it because it's not that complicated. It's describing in a very short way what I just said out there. And I think the answer is, there we go. Question seems like, what's the most popular day of week for these taxi rides by borough? And I think we'll throw in a couple more questions that are just basic light derivatives of that. You'll need a place to run all this. As I said, you can theoretically run it in any kind of world, but the instructions are geared heavily toward Starburst Galaxy. If you have a Starburst Enterprise account through your company or something, or yourself, that's also an option as well. So these instructions just show you how to sign up for free. It's a free solution and service. It's free forever. See Lester dot. You'll get the word of your Lester will be whatever domain name you want. And this won't get turned off in 90 days. What's the free trials will give you about $500 in credits. Now, the good news is the thing I'm going to use today burns 0 credits. So I've been using this for several years now, no cost. And I think the name nowadays comes up and calls it free cluster. Either way, I renamed it as free cluster. I just kind of make that point. It's free. And this is my tool of choice, to be honest, going forward. I use it for just about anything when I need to connect to different data sets all over the place. Okay, so it's going to set you all up getting going with Starburst Galaxy. And then it's going to have a section about creating some of those catalogs. And if you remember what catalogs were, they were those connections to different data sources. So I'm not going to walk you through there, but I'll show you that it set those up. I got about 22 set up. So let me just find New York City. There we go. I got one called, you're going to create one called the New York City Uber rides definition. And I could probably show you what the setup's going to look like. It's going to look a lot like that, and I give you all the information you need. Basically, you need a bucket name. You need some credentials to connect to it, test it out, and that's about it. So it's pretty fast and brief. And the other one that you're going to be asked to take a look at is, I think it's on the next page. There we go. You're going to build another one called Taxi Zone Lookup. And Taxi Zone Lookup is actually Snowflake. So it's a connection to Snowflake. And that information, just like I said, is going to be right here. So that was the Amazon S3 one. I called out some things in yellow that I just want to take a hard look. The one I wanted you to really look at that one. Put your name here. It'll help. We're all using the same bucket. And this thing is a folder. If we use the same name, we'll all confuse each other. The second one is the Snowflake one. Again, create catalog, hit Snowflake. Here's those details. And I should have called it out with yellow, but if you do run this lab, something that happens often, there's a field called private key passphrase, and it starts with some like little default value. You just want to zero it out, make sure it's an empty string. If it fails and you reach out to me, I'll be going. All right, you set up a cluster, you bind them all together, and you have kind of the backdrop, which is what you want to do. That'll take 10 minutes tops, 15 if you're doing 2 or 3 things at once, 5 minutes if you're going really fast. You'll do it all really, really quick. All right, so let's get started with the first major step. The first major step is the fact that I told you that there is some data already on S3. And what I want to do with that, someone told me the bucket name and the path. I want to come to this catalog called New York City Uber Rides. This is my Amazon S3, and I'm going to use a feature we call schema discovery. So I'm going to just tell it the name of the location. So this is a bucket. It's all in the lab guide. This folder within the bucket. I said, hey, I got some data someone told me is already there. And what I'm going to do is go look at that data, not me. The system's going to go look at that data and say, does it look like there's something that I could build a table or a set of tables around, a schema around, and then put it all in a schema named something. So I just let it use the phrase default discovered schema. It's a terrible schema name, but it makes the point. And in fact, what it's going to say is, hey, I found out you told me you want to call it discover schema, but the tables I found out, it looks like there's a table I could call year month. It's going to call it whatever that folder name is. So we can talk about how to change that if you'd like, but for the most part, you're going to say, yeah, that's probably right. It's actually going to say, I think I even found some partitions if you're familiar with what that means. So I say, yeah, go ahead and create that for me. And what's going to kick back here in another second or two is the output of what it was able to run. So he said, cool, I did a few things for you. I created a schema, and then ultimately I created you a table that I called your month. Again, the 3 parts, catalog.schema.table. And here's what I found. And here's that kind of details of where it is, what it is, and that kind of stuff. There's the location, so on, so on, and so forth. Now, you might say, Lester, I could probably do that. There's only 5 or 6 fields. Could I have done it? You could. The real benefit of this tool is if that table's really big and wide, you want to hand crank it, and or do you have a bunch of tables out there? Historically, we would just have done that by hand or have our own kind of pre-built little internal tool. And that's all this is doing, kind of saying, hey, here's what I see, here's what I find. It's a very fast way to build that raw tier. So I said, go ahead and do all that stuff. Meaning, if I went back and looked at my query editor now and open this thing up, and it's no longer running because only the free one shuts down after 5 minutes, is actually going to say, if I open up New York City Uber rides, there we go. I was looking for a new schema called Discovered Schema, and I'm hoping inside of there it is, that table year month that we're talking about. I want to run a query on that. I can right click and say, write me a query, but I already have it written down right about right there. So I'm gonna let the server spin up, and then it's a teeny tiny cluster. Hopefully another few more seconds is up and running here. I'm going to say, show me what you got. Show me some data from the inside of that thing. If it does finish. This is where you tap dance in the demo when you're waiting. There we go. When you're waiting on something to run, you say, hey, la, la, la. Or somebody told me you say, just say the day of the week and say, So he said, it's already running, but he'd say Wednesdays, and then everyone's, yeah. Wednesdays. He said it works for every day of the week. I'm not so sure. Maybe not on Saturday and Sunday. All right, so there we go. There's a peek into just a quick 10 rows of those data sets. Where was that taxi dispatch from? Where was the pickup happening? What was the affiliated base numbers? Roughly the location. Obviously, we don't have all the rigorous geocoding stuff on this. We're just trying to keep it short and sweet. But there we go. Get us off and running. And then when did it happen? Well, you might ask yourself, isn't that also in here? It is, but that might also, for those that know a little bit about things like Hive and partitions, kind of give you some of the things that we hate about date-based partitions. You usually end up having 2 fields. Those things kind of get fixed with Apache Iceberg. Okay, again, that was just a table. And if you do use schema discovery like we just talked about there, and you're not just playing around, you like what that is, or you want to modify, just do a show create table, get it, bring it to however your version, your schemas, that kind of stuff. Adapt it if you want to go and just change a few subtle things like names and that kind of stuff. In general, I'm a big advocate of your raw data ought to be exactly what it was, especially the data. But, could you change the column names and stuff? Sure. That's not going to cause too much grief, but don't change the data yet. Let's do that in that transforming it to more of a silver layer or standardize the layer. Okay. So we built, believe it or not, we did this first part already. We got a land table, a bronze table representing the raw receipt. Now we want to say, and this is where I'm not walking you through the lab guide anymore, all that's in there. But what will we do next is probably say, hey, I want to start to look at that table. So normally I'm going to run queries on it, do all kinds of fun stuff to learn about what data is there and about the data quality. I don't have a lot of time. So I'm going to do a few things like, I don't know, are there already some partitions? I didn't even ask partitions. I just said, how many distinct year months are out there? There's only 6 of these. So it's only 6 rows of data, 6 months worth of data, January through whatever that is, June, way back in 2015. So this did come from a public data set that's kind of getting a little old, but hey, it works. And then I said, great, I figured all that data. I know what's right or wrong about it. It's time to, and that process could take a long time. The first time around, especially, and the more data sets you have, et cetera, et cetera. But let's just say we figured it out and we want to do something with it. So I'm going to create a new schema. I'm going to call it demo. And I'm going to put in that same, we're in that same catalog here. And hopefully we'll have, let's see if it'll pop in right away. If not, it'll show up in a minute here. Yeah, there we go. We have a new schema called demo. There's nothing in it. So discover schemas are raw. Demo can be our, I'm actually going to use it for a combined silver and gold layer. And then I'm going to say, you know what? I looked at that data for a while. And what I like is it's in pretty good shape. Let me just run a few things and we'll talk about it. Yep. Okay. I'll backtrack. Great. Right here around line 53, we said, you know what? For our silver layer, let's call that thing ride pickups. Hopefully our schema may add more value. That's the name we wanted. We changed our names up a little bit. If you remember earlier, the raw table, they were all just varchars. We decided after doing a lot of looking, everything's in good shape. The location IDs as expected are integers and all the dates are in good shape. And, so we said it's going to fit. And additionally, we wanted to use some of those other more high performance storage concepts. We're going to use a file format of Apache Parquet. We want that table. Table format to be Apache Iceberg. For those that know what partitioning is, if you don't, it's just a way to improve performance by using folders, subfolders underneath a table location that align nicely with our queries, our predicates, in such a way that we can read less. So it's a way to scan less data. In Apache Hive, it's kind of a little weird. We got to do some things. If you know about that, great. If you don't, that's okay. For those that do, Iceberg gives us a concept called hidden partitionings that works really well on a number of things. But the really coolest thing I like is when you have a field like pickup date that's something more than just a simple day or something. It's a timestamp. You could cherry pick part of that, a day, a month, a year, or whatever, and say, hey, build the partitioning off of that instead of creating yet another field that is the specific day or something weird like that. That's really just for the folks that have been there and done that. I've got a lot of tutorials that'll walk you through that stuff too. If you'd like to kind of see that in more details, reach out and we'll get you connected. All right, so I built a table and then I just did an insert into that table. As you see there, I think, I didn't even change the names, but if I needed to change the names for standards and stuff, I could have said dispatching base, as, and just call it something. If they were out of a different order, I could put them in the order I wanted. But my solution was in really good shape. The data was really, really good. And basically I did a transform to a better file format, to a better table format that'll perform better for my analytical needs. Chances are it won't be that easy. Chances are you got a lot more tables. Chances are a lot more columns. But, what did we want to do? We wanted to get to the point where I could say, voila, you have a gold table right here, a structured table called the ride pickups. That is, silver version of that raw table. Again, we kept it super simple, super easy, and so on, so forth. But that's what we did. Now, I could take a little time and explain this. I will just simply say these are Apache Iceberg tables. And one of the cool features about Apache Iceberg tables is there's a lot more metadata available to us. And that metadata is available to us from query as well, instead of looking behind the scenes and digging things up. Also, Apache Iceberg and the other modern table formats too, of course, support this concept of versioning or snapshots. So basically what that means is every time I make some kind of change to this table, and it could be metadata, but usually we're thinking about records. We added another 1 million records, we changed 52 records, whatever. We create a new version or a new snapshot as it's referred to. And what could you do with those snapshots? Well, you could query against those previous snapshots that are still around. So you can do time travel querying, show me what that table looked like 5 minutes ago or in this specific version, that kind of stuff. And you can use that same information to rollbacks. Really good for testing. Hopefully not really good for production, but you could use it where you did something stupid and foolish because you didn't do a lot of testing and you realized, oh no, and could you roll your table back to a known point and then progress forward, you could, you're just going to be real careful that anything else that happened obviously would have to be replayed too. But those are some pretty powerful features. We spent a lot of time in some other webinars, blog posts, tutorials, that help you and walk you through all that good stuff. I know I have a lot of stuff online. If that's of interest to you, reach out and we'll talk about it. Okay. What else is going on? Well, as you might notice, I'll run this query just to pull it on the screen. You might notice that this cluster has access to a lot of stuff. One of that, a lot of stuff is this one. This is the other catalog that the instructions set you up to look at. And it has a table down there called the zone lookup. Borough, location ID, and zone. So here it is, borough. Let's just pick some borough. The Bronx. The Bronx is location ID 254. Queens is 253. And those are in zones. So I think the zone can have many, if I remember right, zones can have, whichever way it goes. Maybe it's many to many. But nonetheless, every location is going to be identified with a borough and a zone. It should be multiple boroughs. Nope. Here's Brooklyn. Brooklyn the zones is a sub breakdown. There we go, of the borough. And I can't tell you with all New York pride that says, could a zone be in two boroughs? Does it overlap there? I don't know. But definitely we see with Brooklyn, there are zones, multiple zones within there. So we'll just assume it's like one too many. Maybe not. Okay, that's some additional lookup information. We saw it up here. The reality is, I would even say, hey, that data, if it's in really good shape, it's valid, it's trusted, used for stuff, to me, that is part of my gold layer already. I'm sorry, my silver layer. It's reportable, understandable, blah, blah, blah. And it's also going to make the point I was trying to say earlier, that your silver data, all these zones are just concepts, right? I mean, can they all be in one place? They can, but very unlikely that it truly will. So my logical silver layer for all this includes data that lives in S3 and in Snowflake right now. So I'm going to call that part of my silver layer. So I got two tables now, one over here, one over there. And what you can do with that stuff, like I said, when it's in different places, you can do a federated join. And that's what you see at the bottom here. I joined that cool new gold table, silver table we built, the rights pickup. Take a look at the time. The rights pickup with the taxi zones. And there we go. I appended from that location ID the borough and the zone there. That's simple, quick query, simple join. You can join many tables from many locations if that's what you want to do. But there we go. That's important to me. Now, I'm going to say that answer that you just saw right there, it's really rides by zone. So I'm going to actually go ahead and build me. Let's do that. I'm going to build me a whole new table. I could make it a view or even a materialized view. I decided to make it a table just for giggles, that I actually am putting the result of those hopefully very long table of rides with a relatively short table of ride lookups that are, definitely not going to change for the duration of that ride and everything. I went ahead and persisted that. And I decided that was my first field, my first data set in my gold tier. The users didn't exactly ask for that, but it made a little sense, or maybe they did exactly ask for it. It doesn't matter as much right this moment. But if you look in my demo, and this is my combined silver and gold, there we go. I got my rides pickups and my rides by zone, which I did a select on there. So it was just I did a C-task, a create table based on the results of the query we just saw a minute ago. And there we go. And I could, the way it's implemented right now, it's probably low tech. I would probably think I'm just going to rebuild it periodically or re-add to it would be more appropriate. Lots of ways. I'm not going to handle the maintenance in this 30-minute demo here, but we'd have to not probably, as new data arrives, we need to, add that same data to this table as well, or figure out another strategy. Okay. Now the question was this: what is the most popular weekday by borough? And I might go back to 100% just so you can see a little bit more of the size and scale. And again, all this is in the lab guide. All of this is in the lab guide. And so let me highlight it all. Here I can just put my cursor on it. This is going to run this query. It's not very long. It does a quick CTE, uses a windowing function if you're familiar with that kind of concept. And what did it ultimately give me? It gave me this. Hey, Borough Manhattan, the most popular weekday is Friday. Staten Island, Bronx, Queens, EWR. I always forget the name of the airport over there. These make sense to me. The numbers, I don't know if I love them or not, but let's just say looking at those values, they make a little bit of sense to me. Manhattan, probably got a lot of folks coming into work and that kind of stuff, and maybe they're flying home, or maybe they're getting out of town or whatever on Friday. Maybe that's what's going on. Maybe Thursday, people are heading to the airport. It could mean a lot of this different stuff. Maybe Saturday, Sunday, the rest of the New York City areas, flying out of town, doing something like that. So they wanted to know that. We offered them a way to do that, and we could say, there you go, that's your answer. But to be honest, let's make it easy for them. Let's wrap that up. This time I'll use a view. Just wrap that query with a view that we called Borough Most Popular Weekday View. And then I did a select from it. So there we go. Just give them a quick way to answer that. In fact, that's going to show up over there in our schema as well. So that's our second gold asset here. This view, that table. And then I went ahead and just for giggles and built the second one, the most popular month view by boroughs. So monthly version of that. Give me a second view. And I was just curious, what would be the most popular months? And if you look at them, guess what? They're all around the beginning and the end of summer, except for Manhattan for some reason. Maybe just everyone's back at work come February. So they're doing a lot of taxi rides around town. But the rest of the boroughs are like, hey, it's school's out or school's coming back in. Let's run for the hills and do some vacationing. All right. I got about 8 minutes, so let's see if we can get to the finish line here before this system shuts me down. What we have built is so far, again, we got our bronze. We got one bronze table. We got two gold tables, the cleaned up version of that. I argued silver. I keep calling that gold. The silver, the structured layer, has a Starburst, has a snowflake table, and has the cleaned up S3 table. And then our consume or our gold tier, we created an actual table, the combination of the join there, and then two more views that were really aligned to the reporting needs we have. And we could walk away. That's work done. Probably the next two big things we'd want to do are absolutely apply some appropriate role-based or attribute-based access controls. The lab does give you some steps to play with that kind of stuff. I encourage you if you're interested. To be honest, it's boilerplate, right? That's the stuff we'd expect. We have our own built-in access controls, and we integrate with other access control providers out there. Not all of them, but the popular ones. So hopefully yours is in that if you have that investment already done. And then lastly, after security, we probably want to play with data products. I have very little time. So what I'm going to do is this. I'm going to say, what if I went to my kind of catalogs metadata view? I found that New York City, Uber rides. What if I went into that schema that we've been playing with, called it demo? And what if I use this tool to go in there and supply detail description stuff and add me some owners? Sure, which one of these role-based roles makes sense? I'll leave it like it is. I add some context. Let's let Lester be the primary contact. Add a couple links, to CNN for some reason. CNN.com, and then added some tags like this, that, and the other. Sure, another cities, J, whatever. I added all those tags. And I have at the high level the schema some information. I could go into each one of these tables and start explaining more details. Same way I could hit edit, provide details here. At every single column, I could explain stuff, especially when it's weird stuff. These are all pretty straightforward. But if you have one of those weird fields like we talked about, great place to come touch it and explain what it means, maybe what some of the values mean, apply more tags and that kind of stuff. But at the end of the day, at some point, I'm going to say, you know what? This schema is really curated well. This is a schema that I want to elevate up and offer it as a data product. So in Galaxy, we make it pretty easy. We have a button that's just hey, promote it up, sure. Grab all the data we talked about, sure. And then let me give some more. So my new data product, change, apply, change, whatever. We give it a little bit more description, uses markdown. We can put all kinds of cool stuff with pictures and bolding and bullying, preview it. I'm going to leave it alone. We could even say, should someone be looking at that? We offer this thing called preview. So it says, if you want to offer preview, tell me where to run that thing to do a quick preview, add or change more links, add or change more contacts, and then promote it up. And now it's in that UI experience that we called data products. I hit it earlier. We saw the arrow in space. We saw the Pokemon Go. Now, because I just promoted it with very little details, there's not a lot here, as you saw. At least the data set stuff came forward, but none of the uses examples are going to be here. And while I don't have time today, but I have recorded some stuff, what we would normally do nowadays is we would probably use a combination of human and AI assist to help document this thing. So we definitely have a way to say, hey, if you have a configured LLM, to say, hey, why don't you look through this and make a stab at what all this should be described as in details. And it's going to give you a chance to look at that, approve it. It's going to give you some indication that's where it kind of came from. And then probably as a human, especially if it's my data product that I care a lot about and I want people not to have to ask me a million questions, I'm going to document the heck out of it. I'm likely going to add some of those uses examples that we saw earlier, et cetera. Even our AI agent, when people are using it against a data product, it'll say, they have an option when they get a good answer. It says, hey, put that in the uses example. So it's just this kind of closed loop community of tools and people and processes that can make these data products get more and more highly documented. What I have time to do instead of all that is to say, hey, as you saw, I hit Air and Space and I'll hit my Pokemon Go one and say, yeah, think of this again as a wiki page or whatever you want to kind of think about it, describe it all. If you have links to other things, a team site, departments, all that good stuff, more details, absolutely provide that, point people there. As I said, all that data, those characteristics that you brought forward, they're all going to be here as well. Descriptions and that kind of stuff. No columns found with that one. That's interesting. Not sure what happened there. Hopefully have more stuff in this. Hopefully have nice and good tags. But I think more than anything else, the part that adds a lot of quick value is this, because we're still ultimately pointing people to objects, tables and views primarily. And you still likely aren't just going to do select all from my table. You still probably have further questions of these data sets within a product. And this uses example is a great place to say, hey, here's what, when, where, why. And I don't know about you. I got 3 minutes left. I would just say in my 30 some odd years in this tech field, giving people help to use the data sets takes work. If you're that person that knows this data super well, you are, no matter what, going to be, you've been building a data product since you were the third time someone asked you the same question. How do I find out the Pokemon's grouped together by their primary type? You'll send it to them in email in the old days, and we moved to instant messaging, then eventually start writing it down on the doc, and then you put it on a team site or a Confluence page or something. This is that in a single place, universally. And you know what? These all have a REST API. If you have something similar in your environment, your own bigger data cataloging solution, absolutely, you can build that kind of, it doesn't have inherent free push button bidirectional integration. Today we have a REST API, so we haven't made an integration with one of those tools, first class integration, but all the building blocks are there. If you want to leverage this, support this, integrate with that in the other environment you have as well. So I think with that note, I will stop my jibber jabber. I will look at the Q&A. I think it's going to cut us off in 40 seconds. I will hang around a little bit longer in case I see some questions, but for those that made it this far with me, I appreciate you. I know you're easy on me on the chats today, but don't hesitate to reach back out in any venue you see, including email, LinkedIn, direct message to me, whatever. Again, I thank you so much for all of your time. And I hope you enjoy every bit of your journey with Starburst and Trino and everything we try to do for you guys. So thank you, thank you, thank you.